So in this question, we've been told that a histogram is drawn to represent the data in the grouped frequency table shown. The bar representing the interval 6 to 8 has a width of 5 centimeters and a height of 1 centimeter. We've been asked to calculate the width and the height of the bar representing 15 to 16. Okay, so this is what we'd usually see in a histogram question that wants us to find the dimensions of a particular bar. Now I'm just going to reread through the question. Now I'm just going to highlight the most important parts of the question, the parts of the question that are instructive with what we should be doing. So firstly, the bar we're going to work with initially is the bar 6 to 8. We know its width, we know its height. All of that is going to help us to find some key information that will then help us to find the width and the height of the second bar they're referring to, 15 to 16. Always for this question, a graphical approach is really going to help for you to be able to track what's happening. And the question's testing that you're familiar with the main facets of a histogram. It has bars which have different class widths, unequal class widths. Frequency density is the measure of the height. And any histogram can be drawn with any scale. Two different people producing a histogram may well draw different widths or different heights. So for one particular specific histogram, if we know this information for one bar, we can apply it to another bar. Here's what we should do. We're going to sketch the original bar they're talking about, the 6 to 8, and we're going to label these boundaries. We would always check whether the intervals have gaps in between them. So one of them ends on 8, and the next one starts on 8. It ends on 11, the next one starts on 11. There are no gaps here. We don't need to consider any bounds. If there's gaps, you need to use bounds. If there's no gaps, then no bounds. So let's go ahead and label. Here's the interval we're working with. 6 and 8 means the class width is 2, but we're told its drawn width is 5 centimeters, which means a scale factor to turn 2 into 5 is to multiply by 5 over 2. If you notice, that's the target number divided by the original number. That will always be the multiplication scale factor. Okay, so we know the drawn width can be found using a scale factor 5 over 2. Frequency density. We find frequency density by taking the frequency and dividing by the class width. The frequency we can see from the table is 4, and the class width we've seen is 2. So 4 over 2 gets us a frequency density of 2. But we know that this was drawn 1 centimeter high. That means the multiplication scale factor is going to be 1 over 2. If you multiply by 1 over 2, you can turn any frequency density into a drawn height. This is what we've been looking for. We wanted these two scale factors. They will be exactly the same scale factors that we use for any other bar in the question. So that's the first thing I've put over there on the right hand side. Those scale factors need to be used. Now we can shift our attention to the second interval, the second bar that would be on a histogram. 15 to 16. Let's put down those boundaries. The class width is now 1. When we process the scale factor, we get a drawn width of 2.5 centimeters. Straight away, we found the drawn width of the new bar. We're going to do a similar thing for the frequency density. A frequency of 8, a class width of 1, gives us a frequency density of 8. When we process through the scale factor, 8 multiplied by a half, that gives us a drawn height of 4 centimeters. And there we found both the things we were looking for. We needed to find the drawn width and we needed to find the drawn height. This technique makes it very clear what your process is. This technique maximizes your marks each and every time. Start with the bar you have all the information for and find 2 scale factors. Apply those scale factors to the bar you don't have any information for, and that's how you find the width and the height.